In this section, we're going to talk about creating programs that solve problems. Programming process is made up of a number of steps. The first and most important is that we must understand the problem to be solved. There's no need writing a program if you don't know what you're going to do with it. Develop an algorithm to solve the problem. That is, figure out the steps necessary to solve the problem. Our example program is going to be rather simple. The problem is to output a message on the screen so that when we run our program, it will display some text that we can read. It's very simple. There's not much of an algorithm here other than to say output a message. That is still a step we must accomplish to solve the problem. Then we're going to create a source file whose extension is going to be .java. In that will be the source code that we as programmers would write. We will compile that, create a .class file. That is the bytecode that the Java virtual machine runs. As it executes, the program does whatever it was designed to do. In our case, it will output some text. In this case, we don't really need to test the solution, but certainly in anything non-trivial, we will want to test to ensure that our coding did in fact solve the problem. We'll talk about sources of errors, but first let's go write a little bit of code. This is an editor, happens to be Sublime Text. I choose it because it's the same editor on Linux, Mac, and Windows, so I don't have to relearn and redo commands. All right, to write a Java program, we will start with some code, boilerplate code that simply must exist. We won't understand it for a while. Eventually we will. Public class. I get to name my class. And whatever I name it, that will be the file name out on the hard drive. The book's example is welcome, so I will follow that. So we'll call it welcome. Remember those delimiters? These two braces will delimit or set off the class, all about the class. Now, inside the class, I need to write a method. That is a place where code will execute. So public static void main. Now, this main method is agreed with the JVM as the starting point of our program. This is where the action begins. It may go wildly elsewhere, at least it starts here. And there are a couple more curly braces delimiting the extent or the body of the main method. Inside of it, I'm going to write some code. System represents my entire machine. Out represents the output device, which would be the monitor in this case. Finally, I'm going to say print on one line the message, welcome to Java. This is almost a correct program, almost. I intentionally have left something out to cause a problem. We will attempt to compile it and we will see an error. Let's save it first. I will save as. Notice the name of the class is welcome with a capital W. I have to name my file welcome.java. The name of the class is the name of the source file. So this has to be W capitalized welcome.java. So now it's saved. Let's go look. Here's the subdirectory where I saved it, and I'll do a directory, and there it is. You can see the welcome.java. Now, just to show you that that is what it is, I will type it out, and there's the code. And again, this has an error in it. The slide said errors. I will show you one. I'm going to compile it. Java C. The Java C. The C stands for compiler. So Java compile welcome.java. Press the enter key and it says welcome.java, line 3, error, semicolon expected. And it shows the text, welcome to Java, close paren, but there's no semicolon. Now, semicolon in Java programming, as in a number of other languages, means end of statement. And as I said in the previous session, almost all statements end in a semicolon. It's like a period in English. It says we're finished. This statement is finished. So let's go fix it. And here we are. System out. There's the message. Closing parentheses. It says it needs a semicolon. So I'll type a semicolon and save it. Now let's go try to compile it again. Java C and the name of the file. And there it is. No errors this time. The compiler read the code, analyzed it for any types of errors that it could find. Errors that the compiler can detect are called compilation or compile time errors or syntax error. What it was is I didn't finish the statement. I left it dangling. no semicolon, means I never told the compiler that that statement was finished. So it looks at that and says, okay, but then it sees that closing brace that says the method is finished. It says, how can you finish the method without finishing the statement, which is a piece of the method? That's got to be a problem. So that issued that error message. So the compiler does a lot of checking to make sure everything is just right. Now, there's two other types of errors that show up, and they're harder to fix. I'll discuss them later, but let me briefly introduce them. One is runtime. I can run the code and it be working okay for a while, and then all of a sudden something happens and the program crashes. Well, those are runtime errors. For example, a divide by zero, integer divide by zero. I could be dividing numbers and all of a sudden divide by zero, and it says, whoa, undefined, crash. So although some or most of the program runs, useful output is made, eventually the program crashes because something that should not happen happened. The third type or category of errors is what we call logic errors. That's when I, the programmer, have misunderstood the problem or misstated the algorithm or miscoded the implementation of the algorithm, and there's something just simply wrong with it. Thinking error has crept in, and the program runs and it doesn't crash necessarily, but the results are wrong and maybe only subtly wrong. Logic errors are the hardest to find. Okay, let's run this. I'll type in the word Java. That's the command on any machine that says run the Java virtual machine, and it will run our code, but it doesn't know the name of our code, so I have to tell it. Welcome. Now, don't type welcome.class. The runtime will give you an error. I'll show you that. It says could not find or load welcome.class. What we do not do is include the .class. Although that is the file with bytecode in it, we don't include that extension. We just say Java run the welcome class, not the file welcome.class. It figures it out. So we run it, and this time it worked, and we see the output, welcome to Java, which is what we had anticipated was correct out. All right, we talked about these errors. Syntax errors are the ones that the programmer mistypes or doesn't think fully about, but the compiler catches them and says, that's not quite right. You didn't specify that line of code correctly. There's some sort of error. The runtime ones are where the program runs, but something happens that shouldn't and it crashes. Logic errors are the ones that the programmer makes because of some sort of wrong thinking or misunderstanding of the problem. For a while, they may not even be noticed. Logic errors can be very tricky. The best thing we can do as programmers with a logic error is test the program. Give it some bizarre input, unusual situations to deal with. Test it. Verify that it is working the way you expect. And if it isn't, find the problem and fix it. Quickly about the JDK. The Java Development Kit must be installed before we can compile anything. I have already installed it, obviously. The Java C and the Java command are set up in the path so that I can execute them. If you're not sure how to set things up, check out my playlist called Software Installation and Setup. That will help. There's a lot of Google sites that will help. YouTube in particular can help. Sometimes it's difficult to find a good, succinct one that makes sense. So if you need help, ask for it, look for it. Later on, I'll be using Eclipse, which is an IDE, the Integrated Development Environment. Using an IDE is nice. It prevents you from having to worry about typing in command Java-C, Java itself. You just click a few icons and all that happens, or it happens behind the scenes and you don't even notice it happen. It really makes development of programs easy. Command line programming is a little harder, but the programmer understands what's going on and controls it much better. I prefer command line, but I use Eclipse a lot too. It's personal preference. And as we saw, the command line or shell uses the Java-C command to compile the .java file to the .class file. But again, when we're running it, we don't specify that .class. We just tell it the name of the class, which in our case was welcome, not the name of the file, which was welcome.class. And finally, the execution. After the program is written and compiled, we execute it. That is to run it. The IDE hides these details, as was said. Executing from the command prompt uses the Java command, as you saw. Either way, check the results and validate the problem's solution. That is, test it. Make sure it's working the way you expect.